You're looking at a desert, dry, empty, the kind of place where farming shouldn't be possible, and for most of history, it wasn't. But a few years ago, something changed. Israel started pumping millions of gallons of desalinated seawater into one of the driest regions in the Middle East, the Negev Desert. And instead of getting swallowed up by sand and sun, that water did something no one expected. It turned into farms. So how exactly did they turn barren sand into fertile farmland? And can this be done elsewhere, say in parts of California, Africa, or the Middle East? Because this is not just a story about Israel, it's a story about what happens when you stop asking, can we do this? And start asking, how? The Negev Desert is not just dry, it's aggressively dry. It covers over 13,000 square kilometers, more than half of Israel's total land area. To put that in perspective, that's nearly the size of the entire country of Qatar, and yet for most of its history, the Negev has been considered unusable, too dry, and too barren to support meaningful agriculture. Rainfall here is minimal, often less than 100 millimeters a year in some regions. Not enough to grow crops, not even enough to reliably fill a backyard pool. There are no rivers to tap into, no permanent lakes, and the groundwater that does exist, most of it is too salty for drinking, let alone farming. The soil is not much better. It's sandy, low in organic matter, and easily eroded by wind. Without trees or vegetation to hold it together, the landscape is constantly shifting, beaten by sun and stripped of moisture. This is the kind of environment where farming, in the traditional sense, simply doesn't work, and yet Israel had no choice but to try. From the moment it was established, Israel faced three hard limitations: scarce water, limited arable land, and a rapidly growing population that needed food and stability. By the 1990s, the pressure had reached a tipping point. Freshwater reserves in the north, like the Sea of Galilee, were dropping below emergency levels. Aquifers were being overdrawn, and cities were starting to compete with farms for what little water was left. Meanwhile, over 60% of Israel's land, mostly in the Negev, remained undeveloped. If you looked at a satellite image, it was obvious. A densely packed population clustered in the green north and center, with vast empty brown space stretching south. That imbalance was not just economic, it had strategic consequences too. The Negev bordered Egypt. It was underpopulated, underutilized, and increasingly vulnerable. The solution, at least in theory, was simple: make the Negev productive, but practically, that meant rewriting how agriculture works. Because here's the core problem: you can't grow food without water. And in the Negev, water doesn't fall from the sky, it doesn't flow through rivers, it doesn't sit in deep underground reserves waiting to be tapped. So if Israel wanted to farm this land, it had to create its own freshwater supply, artificially, consistently, and at scale. That challenge, producing water from nothing, would lead to one of the most ambitious agricultural experiments of the modern era. Not just to survive, but to grow. In the 1950s and 60s, Israeli leaders declared that making the desert bloom was not just a nice slogan, it was a necessity. It was a logistical problem, a resource problem, a question of how do you bring water to where it doesn't exist, and then make sure every drop is used as efficiently as possible. The answer would begin on the Mediterranean coast, with seawater, and a technology that would completely change the equation. When a country runs out of water, most governments tighten usage. They ration, they restrict, they wait for rain. Israel didn't wait. Instead, it built machines that make fresh water from the sea. And that's not an exaggeration. The country's entire approach to its water crisis changed in the early 2000s, when it made a massive national investment in something that most countries considered too expensive and too energy intensive to rely on long term. At its core, desalination is exactly what it sounds like, removing salt from seawater to make it usable. But the technology that made this viable for Israel is more specific: reverse osmosis. Here's how it works. Seawater is drawn in from the Mediterranean. It's pre-treated to remove debris and microorganisms, then forced through a series of ultra-fine membranes under high pressure. These membranes are specially designed to block salt molecules and other impurities while allowing only water molecules to pass through. The result? On one side of the system, you get clean, drinkable fresh water. On the other, highly concentrated brine, which must be diluted and carefully returned to the sea. This process is energy intensive, yes, but not as much as it used to be. Over the years, Israel has invested heavily in making desalination more efficient. That includes using energy recovery turbines, building plants near power stations, and integrating desalination into its broader national water grid to minimize waste. The scale of this transformation is staggering. In 2005, Israel opened the Ashkelon desalination plant, followed by facilities in Hadera, Palmachim, and eventually the Sorek desalination plant, currently one of the largest in the world. Sorek alone produces over 624,000 cubic meters of fresh water every day. That's enough to supply nearly 20% of the country's domestic water needs from a single facility. And that was just the beginning. As of today, more than 75% of Israel's household water comes from desalination. That's a reversal of fortune. What used to be a vulnerable, rain-dependent water system is now almost entirely climate independent. But this fresh water doesn't just sit in coastal cities. That's not where it's needed most. Israel built a system to move this water inland, across hills, through tunnels, and deep into the southern desert. In other words, desalination was never the end goal. It was just step one in a much larger plan, turning seawater into farmland. Of course, desalination isn't perfect. The environmental impact of brine discharge is still debated. The energy cost, while lower than it once was, remains significant. And the infrastructure investment isn't cheap, but when the alternative is drought, crop failure, and food insecurity, cost becomes relative. And here's what made Israel's approach different. It didn't treat desalination as a backup. It made it the foundation. That foundation would go on to support everything that followed, especially the effort to bring water not just to people, but to deserts that had never seen a drop of rainfall in months. And the next challenge? Getting that water to the right places, at the right time, in the right amount. Desalination gave Israel a new source of fresh water, but the real question was, how do you move that water from the coast to the middle of a desert? This was not a simple logistics problem. It was an engineering challenge on a national scale. Because while desalination plants like Sorek and Ashkelon sit comfortably along the Mediterranean coast, the Negev Desert, the region that most needed water, sits over 200 kilometers inland across a landscape of rocky hills, dry valleys, and sparse population. Moving millions of liters of water per day across that kind of terrain requires more than pipes. It requires a coordinated, high-efficiency, smart water infrastructure, one that Israel had been quietly building for decades. It starts with the National Water Carrier. Originally completed in the 1960s, the National Water Carrier was designed to transport water from the Sea of Galilee in the north to the populated center and arid south. It was Israel's first major water redistribution system, and for years it served as the backbone of the country's freshwater supply. But by the early 2000s, it needed a serious upgrade. With desalination coming online, Israel began retrofitting the national water carrier to handle desalinated water. A different kind of flow with different pressure, chemical characteristics, and demand patterns. New pumping stations were installed, pipelines were re-engineered, smart meters and sensors were embedded throughout the network. The result? A hybrid water grid capable of routing desalinated water from the coast to inland towns, cities, and eventually remote desert farms. But this network doesn't just deliver water, it monitors it in real time. Using digital flow meters, automated valves, and centralized control systems, water managers can track pressure, flow rates, and consumption across the entire country. If a leak appears, it's detected immediately. If demand spikes in one region, say during peak irrigation season, water flow is automatically adjusted. And just as important as moving the water is storing it. Throughout the Negev, Israel built strategic reservoirs, some open air, some covered, designed to hold excess water during off-peak hours and release it during times of high demand. These aren't just backup tanks, they're an integral part of the supply chain, smoothing out daily and seasonal fluctuations in agricultural water needs. The system also includes priority-based water allocation. Drinking water always comes first, followed by agriculture, then industry. But because of desalination and water recycling, there's now enough flexibility to supply all three reliably. And speaking of recycling, this is where Israel pulls ahead of nearly every other country on the planet. More than 85% of Israel's wastewater is treated and reused, primarily for agriculture. This includes sewage from cities like Tel Aviv and Haifa, treated to near-potable standards and then piped into the Negev to irrigate crops. In most countries, this would be controversial. In Israel, it's standard practice and a cornerstone of water policy. Together, this system makes it possible to do what was once unthinkable: deliver a constant, reliable supply of water into one of the driest environments in the region. And with the water problem solved, Israel could finally turn to the next challenge. How do you actually grow crops in a place where every drop is precious? That's where the biggest breakthrough of all comes in: drip irrigation. If you're farming in the desert, one thing becomes painfully clear: you can't afford to waste water. Every drop counts, literally. That's why Israel didn't just focus on how to get water to the Negev, they reinvented how to use it once it got there. And it all comes down to one of the most influential agricultural innovations of the 20th century: drip irrigation. The idea sounds simple. Instead of flooding entire fields or spraying water over crops, drip irrigation delivers water slowly and directly to the base of each plant. A network of plastic tubes, fitted with tiny holes, called emitters, releases controlled amounts of water, one drip at a time, right where the roots can absorb it. No runoff, no evaporation, no waste. This technique was not imported from somewhere else. It was invented in Israel by an engineer named Simcha Blas in the 1960s. He discovered that plants responded better to slow, targeted watering, and that doing so dramatically reduced the total amount of water needed. Since then, the technology has evolved. Today's drip systems are computerized, sensor-driven, and even connected to satellites. They can monitor soil moisture, plant health, and weather forecasts in real time, automatically adjusting how much water is used based on actual needs. Here's what that means in practice. Drip irrigation can cut water use by up to 70% compared to traditional methods. It allows farmers to irrigate sandy, sloped, or uneven terrain, perfect for the Negev's challenging geography. It also reduces weed growth and minimizes the spread of plant diseases by keeping leaves dry. In short, it gives more yield with less input. Exactly what desert farming demands. But drip irrigation is not just about pipes and sensors. It's a mindset. Farmers in the Negev don't think in terms of hectares, they think in liters. Every decision is calculated. How much water a tomato plant needs per day, per growth stage, per soil condition. Companies like Negev, based in Israel, have become global leaders in this field, exporting drip technology to over 100 countries. But it all started here, as a direct response to the question, how do you farm where water is scarce? And the answer was not just to bring in more water, it was to make every single drop work harder. Once the water problem was solved, both in supply and delivery, something remarkable began to happen in the Negev. Farms started appearing, not just experimental plots or government showcases, but real functioning farms, planting, harvesting, and selling crops from one of the driest landscapes on Earth. So what exactly are they growing? A better question might be, what aren't they? Thanks to precise irrigation, tailored soil treatments, and climate-controlled environments, farmers in the Negev are now growing a wide range of crops, including tomatoes, which thrive in the region's warm climate and sandy soil when properly irrigated. Cherry tomatoes, in fact, became so successful here that Israel began exporting them under the label desert grown. Dates, especially the prized medjool variety, which benefit from hot days, cool nights, and controlled watering. Strawberries, grown in shaded greenhouses using vertical farming methods to conserve space and maximize output. Even herbs, peppers, eggplants, and flowers, many destined for European markets. So how is this possible? A big part of the answer is controlled environments. In much of the Negev, crops are not exposed to the full force of desert conditions. Instead, they're grown under shade nets, plastic tunnels, or full greenhouses where temperature, humidity, and light are managed. These systems not only protect crops from heat stress, but also extend growing seasons and reduce pest pressure. Another factor is soil engineering. The natural soil in many parts of the Negev is poor and sandy, but with the right mix of compost, minerals, and organic matter, farmers have transformed unworkable ground into productive land. In some cases, they don't even use soil at all, relying instead on hydroponics or treated sand paired with nutrient-rich water. Farms are often organized as moshavim or kibbutzim, cooperative communities where resources, labor, and profits are shared. These communities were pioneers in desert farming, and today they operate with high-tech greenhouses, research labs, and even on-site desalination units. And it's not just about feeding local communities. A significant portion of these desert crops are exported, bringing in revenue and establishing Israel as a world leader in arid zone agriculture. This is what happens when innovation meets necessity. A desert that once grew nothing now grows food at scale. It didn't happen overnight, but today, when you drive through parts of the Negev, especially near places like Be'er Sheva, Hatzerim, or the Arava Valley, you'll see something that looks almost out of place. Fields, rows of crops, greenhouses, orchards, and not just a few, entire stretches of land that were once dry, cracked, and windswept are now producing fresh fruits and vegetables, season after season. This transformation wasn't just technological, it was also ecological, economic, and deeply human. Let's start with the land. Converting desert into farmland comes with risks. Salinity levels can rise, soils can degrade, native ecosystems can be disrupted, but Israeli researchers and farmers track these factors relentlessly. They conduct routine soil tests, monitor for nutrient depletion, and rotate crops to prevent long-term damage. Some areas even grow crops using brackish water, salty groundwater that's been partially treated. Not every country has the tools or oversight to make this work, but in Israel, environmental monitoring is built into the farming system itself. Desert farming has brought new life to rural communities. Many of the early settlements in the Negev were struggling to survive, but now, with the introduction of high-tech agriculture, they've become innovation hubs. Some even export not just produce, but knowledge through partnerships with researchers and visiting delegations from around the world. There's also a growing push to include Bedouin communities, many of whom have historically been marginalized. Programs are helping train Bedouin youth in agri-tech skills, creating jobs, income, and a shared stake in the land. Economically, the impact is hard to ignore. Israel exports billions in agricultural goods, some of it grown in the Negev. More importantly, the agri-tech sector itself has become one of Israel's fastest growing industries, driving investment and research across disciplines. But perhaps the most powerful result is symbolic. This isn't just about growing food, it's about proving that deserts aren't dead zones. That arid land can become productive with the right systems in place. That water scarcity, while serious, is not always a death sentence for agriculture. And that when governments, engineers, and farmers align around a shared goal, even something as ambitious as making the desert bloom, real change is possible. So we know it works in Israel. The question now is, can it work everywhere else? The short answer, maybe. The longer answer, it depends on how much you're willing to invest and innovate. Let's start with the obvious challenge. Desalination is expensive, not just to build, but to operate. Reverse osmosis requires high pressure, advanced membranes, and most importantly, a lot of energy. For wealthy, tech-forward nations, this can be managed, but for many countries facing desertification, especially in Africa and parts of Asia, that kind of infrastructure is out of reach, at least for now. That's where solar-powered desalination comes in. New pilot projects in places like Morocco and Saudi Arabia are using concentrated solar power to drive the desalination process, cutting down on emissions and reducing long-term costs. If these systems can scale, they could help break the energy-water cost barrier. Then there's the challenge of knowledge transfer. Even with the right tools, success depends on trained people. Drip systems must be installed correctly, monitored daily, and adjusted seasonally. You can't just drop off equipment and walk away. That's why Israel has launched initiatives like Mashav, its international development agency, focused on training agricultural experts from other nations. From hands-on workshops to online courses, thousands of professionals from over 130 countries have studied Israel's methods and returned home with new strategies. What began as a local solution for a small desert country is now influencing global agriculture. Israel didn't just transform its own landscape, it packaged the tools, the techniques, and the know-how into something other nations could adopt. And today, Israeli desert farming isn't just a national achievement, it's an international export. Companies like Netafim, Ndrip, and IDE Technologies are exporting Israeli-designed systems to more than 100 countries. From drip irrigation kits for smallholder farmers in Kenya to desalination plants serving drought-stricken cities in India, the impact is wide-reaching. Take California, for example. Faced with its own water crisis, California has turned to Israeli firms for help. In places like Fresno and Bakersfield, Israeli drip systems are being used to irrigate almond groves and vineyards more efficiently, cutting water use while maintaining yields. Engineers from both sides are now collaborating on salinity management, soil diagnostics, and sensor integration. In India, Israeli technology has been deployed in dry states like Gujarat and Rajasthan, where extreme heat and low rainfall mirror the conditions of the Negev. The result? Increased productivity, lower water use, and growing partnerships between the two countries. In Africa, Israeli-led programs are helping train farmers in desert irrigation and low-tech hydroponic systems. In places like Rwanda, Ghana, and Ethiopia, the goal isn't just to improve crop yields, it's to create long-term resilience in the face of climate change. But exporting this model is not always simple. Desalination, for instance, requires a stable electricity supply and significant upfront investment. Many developing countries can't afford large-scale reverse osmosis plants. Others struggle with political instability, making long-term infrastructure projects difficult to maintain. That's why Israel's international approach is not just about selling equipment, it's about sharing systems, customizing solutions to fit local realities. Sometimes that means combining solar power with small-scale desal units. Other times it means training local technicians to build and maintain their own drip networks using recycled materials. At its core, the model is about doing more with less. And in a world where climate change is expanding deserts and shrinking freshwater supplies, that philosophy is more valuable than ever. But beyond logistics, there's a bigger mindset shift taking place. Farming used to be about land and rain. Now it's about data and precision, smart sensors, moisture meters, AI algorithms that predict plant needs days in advance. And that's the direction global agriculture is heading. And while no system is perfect, Israel's Negev model is a clear proof of concept, a working blueprint. It's a glimpse into what farming might look like, not just in deserts, but in any region where water is scarce, climate is unstable, and the stakes are high. Because in the decades to come, the ability to grow food where nature says you can't might just be the most important skill on Earth. So, could this work in your country? Let us know what you think in the comments. Thanks for watching, see you in the next one.